question 3. So a fairly unusual question to come up at M1, but pretty straightforward, I think. So we're just looking at vectors in the context of forces. So for part A, we're given that P is in equilibrium. That means all these forces just cancel out. So how do we make the i's cancel out? Well, we've got 7 plus 5 is 12, so P therefore needs to be minus 12. I've done that over here. And secondly, for Q, well, Q is a number of J's, so again the J's all need to cancel out, so we've got a minus 9 plus a 6 plus Q having to equal 0, because as I said they're all in equilibrium. Minus 9 add 6 is minus 3, so Q needs to be plus 3 in order to make it 0. Now for part B, we're now told that the force F3 is now removed, so we're just left with F1 and F2. We're being asked to work out the resultant of F1 and F2, which is R. Well, resultant just means add the two together, so very straightforward, just adding these two together. 7i plus 5i is 12i, minus 9j adds 6j is minus 3j. So that's this. Easy peasy. Right, now part C, we're just being asked to work out the angle to the nearest degree that the direction of R makes with J. That's significant. So let's just think about R alone to start with. So that's 12 to the right and 3 down. 12 to the right and 3 down. So that's just generating this little angle X, which clearly we can just work out with SOHCAHTOA, opposite over adjacent. So tan X equals 3 over 12, X equals 14 degrees. So that little acute angle here within inside the triangle is 14. Now we're being asked to work out the angle this vector makes with J. Now remember, J is just really the y-axis. So we're asked, so the angle that we need is from here all the way around to here. So that's obviously a right angle plus the x that we've just worked out to be 14. 90 plus 14, 104 degrees.